ICSU and ESM Science Forum with the theme Cutting Edge Science and the Future of Mankind. To begin with the forum, I would like to call upon Dr. Hong Kam Lee, Director General of Korea Polar Research Institute, to chair the session and introduce the speaker. Please welcome.
So, good morning, everyone. I'm Hong Kam Lee from Korea, and I'm as chair. First of all, I'm very grateful for ICSU and the government of Malaysia for the support to ROAP in the second 5 years phase. And as you know, the global sustainability is the key issue for all, and all countries have developed cutting-edge science, and we are also trying to share our experience to more as a better life of mankind. And as chair of this science forum, I am very delighted to introduce two members of RCAP. And as a first speaker is Professor Toshio Yamagata from University of Tokyo. He will give us a talk, and the title is Using Cutting-Edge Science to Understand Climate Variation and its impact on society. So please, Professor Yamagata.
Thank you very much for a nice introduction. Actually, I moved from Tokyo University to the JAMSTEC, so my affiliation is really different. Sorry for that. Always transition phase after aging. First of all, I'd like to thank you, you all, for providing me a nice opportunity to give my presentation right after the epoch-making event of the signing ceremony of ICSU and the government of Malaysia. My talk is totally different from the previous Nobel laureate, but please forgive me. So, title is Cutting Edge Science to Understand the Climate Variation and its Impact on Society. Maybe you know we have a climate change. Professor Lee already explained in more details, but I focus on the climate variation. Sometimes people misunderstand the climate change and climate variation the same. Particularly in our government, Japan, if you translate that in Chinese character, it's almost the same, and cause a lot of misunderstanding. And I explained something in your note. And the climate change and climate variation, and climate variation actually is a mother of the abnormal weather or extreme events. So to understand climate variation is very, very important. And typical modes of climate variation is El Nino and Indian Ocean Dipole I discovered 1999. Here you can see those locations. This is El Nino or La Nina. This is dipole, Indian Ocean Dipole, positive phase and negative phase. And recently, this El Nino changed its character. And I put the name El Nino Modoki. And this global influence is very much different from El Nino. Climate itself is evolving under the pressure or under the stress of global warming. And we scientists pay more attention to that kind of things, rather than directly go from the climate change to extreme events. Many people misunderstand. Climate change directly generates abnormal weather. That's completely wrong. Now let me show the heavy snowfall during the winter of the year 2005 and 2006. You can see a northern part of Japan facing the Sea of Japan. It's like this, about sometimes 10-meter height of snow. Also this year happened because of La Nina or La Nina Modoki. And this is agricultural loss. In the year 1993, we had no summer in Tohoku area. Tohoku regions, northern part of Japan, always suffer from natural disasters. 1993, due to climate variations, and last year, earthquakes, tsunami. And the loss is enormous, 17 billion US dollars, no harvest. And if this kind of thing happened 100 years ago, then famines and others, or a family kill kids or sell kids. And that kind of actually happened, even in Japan. Now I'll show some Australian agricultural things. This is a wheat product of Australia. You can see this year start from 1950 to year 2007. This is a product. This, because of the technological development, there is a clear growth, but at the same time, sudden drop. Okay, and this drop is all related to El Nino or Indian Ocean dipole, climate variations. So we must understand what generates El Nino and Indian Ocean dipole. This shows the summary of the Indian Ocean dipole impact in the year 2006 boreal fall. You can see some dry regions here and wet regions here in the Indian Ocean. This phenomena caused a lot of troubles all over the world. This is not well known still in the climate community, unfortunately. Many people think everything is related to El Nino. That's also wrong. And if once we have this kind of phenomena, Indian Ocean dipole, then we have a flood in the near Kenya regions, Eastern Africa. So more than 1 million people in Kenya, Somalia, and neighboring countries were affected by this flooding. And this year, I'll show later on, we predict very dry conditions. We are very much afraid of famine starts again in East Africa. And my prediction is correct. This is a severe drought in the Australia, and also your region suffer from the forest fires and the cloud, smarter regions, and cause a lot of trouble in the airplane. Perhaps you remember year 2006. It's due to dipole. Let me show the beautiful scenery in Australia. This is my friend, my customer, Australian farmer, John Welsh. John Welsh always check our homepage, and they use that for their agriculture. Beautiful scene, but autumn 2006 is like this. One problem of this picture is John's wife is laughing. That's a problem, but anyway, a miserable situation here. So El Nino, La Nina, and dipole very important. Let me first talk about El Nino, La Nina, one of the most important climate modes on this globe. Actually, La Nina was named by my colleague George Finanda when I was in Princeton. And this is a picture of anomalous sea surface temperature anomaly. This is El Nino. Normally we have the warm water here, but sometimes moves eastward. Okay, that's El Nino. And associated with that oceanic phenomena, we have atmospheric counterpart. And we have a very big oscillation. Center is Darwin here, another center is Tahiti. Normally, pressure in this region is low, atmospheric pressure is low. Atmospheric pressure here is high. So we have the pressure-driven wind, that's easterlies or trade winds, and accumulates warm water here. But once we have El Nino, that warm water moves eastward, and atmospheric pressure becomes low here, okay? That kind of oscillation occurs. This was discovered by the Lockyer, actually. Lockyer started Nature, amateur astrophysicist. And many people think this was discovered G.T. Walker. Actually not. It's discovered by Lockyer, who started journal Nature. And this time series shows the relationship between atmospheric variable I showed southern oscillation and also sea surface temperature anomaly. So this is east-west atmospheric seesaw, like time series, like this. This is a sea surface temperature anomaly of Peru. This is instrumental data. You can see those two, atmospheric variable and oceanic variable, very much coherent. Okay? So El Nino is ocean atmosphere coupled phenomena. This is a schematic picture of the El Nino and La Nina. I will try to amuse you a little bit. Anyway. There is some music, but anyway, let me give me time and okay. Now I hope this works. Here. This is the time series of El Nino, sea surface temperature anomaly, and high temperature is high tone, low temperature is low tone. Just compounded that. Amazingly, many scientists use the eye to do research, but I think we scientists must also utilize ear, right? Musicians use the ear, perfect detection of the important things. This is beautiful sound, perhaps the cry of nature under the pressure of the global crisis. Anyway, so this orange color shows the sea surface temperature anomaly or atmospheric temperature anomaly, warm conditions. And this blue shows the cold conditions, right? And this cloud shows the wet conditions. So once we have El Nino, the impact is global, and particularly you might be interested in this region. Once we have El Nino, very dry conditions in this part of the world, and also India, okay? And also Japan area is cool summer, sometimes no summer, as I showed in 1993. But now, situation is changing, also under the pressure of global change. El Nino changed the face now. In recent years, the Central Pacific warming is more frequent, and off Peru, SST is low, and also Western Pacific is low. So higher mode of that kind of phenomena occurs, rather than the gravest mode of El Nino. And I put the name El Nino Modoki. Modoki is a Japanese word. Looks the same, but actually not. If you go to the sea, some animal looks like the seaweed, but actually it's animal. And once we find that kind of thing, we put the name Modoki. Okay? I don't know you know the gum Modoki. Gum Modoki is a Buddhist cannot eat meat, so made meat-like things by using tofu. Okay, that's a gum Modoki. But anyway, like tsunami, I try to make this world, international science world, right? So this is just a complicated analysis, but we have empirical orthogonal function analysis. I don't want to go into details. But the first mode, of course, catches El Nino or La Nina type things. But second mode is Central Pacific warming or cooling, and just opposite surrounding those two. And this phenomena, frequency of this phenomena is more frequent nowadays. And even the atmospheric circulation is very much different. The top view is El Nino Modoki. Date line is here along the equator. This is of Peru. This is Indonesia or Malaysia region. Once we have El Nino, this updraft. This is troposphere and downdraft. So once we have El Nino, this region of the world become very dry. And no, this is, sorry, this is the El Nino. This is Modoki. So Modoki case near the Central Pacific dateline, updraft occurs and downdraft. And El Nino updraft occurs in the Eastern Pacific and downdraft here, okay? So severe drought here. So pattern is very much different. And this is a schematic view because Nature asked me to write a review article about this recently. So this is El Nino, this is La Nina, this is El Nino Modoki, this is La Nina Modoki. This winter we had this. So a lot of strange climate variations all over the world. And this is climatology. Now let me go to the Indian Ocean. Another important climate mode discovered by a group in 1999. Year 1994, we had extremely hot conditions in Japan, also Europe, Mediterranean regions. It's a teleconnection because of this. And the origin was in the Indian Ocean, very dry condition here, very wet condition here. Physicists call this kind of phenomenon is a dipole. So I put the name of dipole. Then cause a lot of trouble. Actually, some scientists, when they meet, oh, you have a nice job. But behind the scene, they say, maybe that's a crazy idea. That medical doctor says that's a dipole, right? Anyway, this is El Nino, so very wet conditions. Now this is a dipole, dry and wet conditions. This occurred in 1997. Two things occurred at the same time, El Nino dipole, and caused a lot of trouble in weather agencies. Let me show the satellite imagery. Left-hand side shows the sea surface topography change. Warm color shows the high sea level, and blue shows the low sea level. You can see eventually, this is low sea level, and high sea level here. Okay, this is the height of the positive dipole. This part is sea surface temperature. So if you know the existence of dipole, then this type of picture shows a very nice one, something like a laboratory of geophysical fluid dynamics. But before our discovery, many people thought this is just the Indian Ocean is a messy, dormant ocean. But it's a beautiful experimental ocean basin once we have new cutting-edge science. This is taken from our Nature paper published in 1999 with Saji, a young scientist from India. We worked together with a young postdoc in Tokyo and discovered this. In the May, June, July, something like that, southeasterlies strengthened and evaporation cools sea surface temperature. At the same time, coastal upwelling occurs because of Ekman theory and others. I don't want to go into details because it takes 1 hour to teach that kind of dynamics. And then atmospheric pressure becomes high above the low sea surface temperature. And then that grows like this. Then along the equator, we have the easterly anomaly that advex warm water in the westward. And above the warm SST, the atmospheric pressure becomes low. So we have the east-west pressure gradient that accelerates also wind, easterly winds. Then that accumulates and we have the positive feedback and grows and reaches the mature phase of the dipole. But quite interestingly, this region, we have the monsoon, and the winter monsoon blows like this, just opposite, and kills these interannual variations suddenly. So this interannual mode is strongly locked to the seasons. Season is so strong. And this clearly shows the evolution. This is January, this is January. And so east-west SST contrast grows and suddenly dies down when winter monsoon comes. And this is easterlies, also grows and suddenly die down. This also shows how the ocean atmosphere coupled each other. And this shows atmospheric part of the Indian Ocean dipole, like a southern oscillation of El Nino. You can see some east-west oscillations. Quite interestingly, this eastern pole covers Darwin. When I was in Princeton in the 1980s, many people puzzled why Darwin Tahiti is used for El Nino or Southern Oscillation Index. Southern Oscillation Index is not a nice index of El Nino, and they couldn't understand at the time, me too. But now we understood. Darwin, in some sense, contaminated by other phenomena, brother of El Nino. Here El Nino, here brother of El Nino. And I said brother of El Nino, and it caused a lot of trouble with Christianity society. There is no brother of Jesus Christ. So this is a schematic picture of the dipole. This is negative dipole, this is positive dipole. And let's listen to the music again. A little bit Asian flavor. This part. I like this part. Anyway, this is also a time series of dipole. And this is a global influence of dipole. Here the SST is cool and the SST is rather high, and wet conditions, Eastern Africa, and dry conditions here. And also Australia suffers very dry conditions. Year 2006, 2007, 2008, 3 consecutive dipole and had a disaster, brought a disaster to Australia. That's why the Australian farmers always check our homepage. And also very hot conditions in Japan and also Mediterranean countries. And this sometimes provides you a very nice thing. For example, if you like port wine, dipole year gives you, this is like a secret information for you, but if you like a port wine, just check the dipole year. Very nice. Now, as I showed, dipole and El Nino sometimes occur at the same time. And there might be some link, or might not be some link, any link. The G.T. Walker's period, early 20th century, Indian summer monsoon rainfall and Southern Oscillation Index closely relate each other, like this. Correlation is very high, almost close to 1. That's why the G.T. Walker introduced the name of Southern Oscillation, and Lockyer actually discovered. But in the recent period, correlation is 0.1 or below. So the reason of those low correlation is just 1994 we had dipole, okay? Once we have positive dipole, that brings a nice rain in the eastern part of India. Even if we have El Nino and try to give India very drought, bad monsoon, but once we have dipole, that gives you a nice rain. So that kills, okay? So climate itself is evolving. Like animals' gene, right? The dormant gene sometimes occur and gives you a new phenomena. So now the significant Indian Ocean SST warming, about 0.6, 0.7 degrees per 50 years. Because Indian Ocean, we have the Eurasian continent and no link with the cold ocean. And that's a serious problem. And more frequent occurrences of Indian Ocean dipole that brings abnormal weather in the world. So Indian Ocean is becoming one of the most important drivers of recent climate variations under the global warming stress. So we must pay more attention to that kind of thing. Now, problem is now we understood physics. Time to predict, go into the future. And we, many years ago, we introduced Earth simulator. Now, this is old version. I'll show the 10 years ago version. And this is atmospheric GCN, and this is ocean GCN. We coupled. Now, this is a virtual Earth. We realize this. Dipole occurs and El Nino occurs. This is La Nina. And so virtual Earth now captures El Nino or La Nina or the dipole, okay? next thing to do is to put real data in the system and see what happens and predict future like a creature, okay? And we did a lot of such experiment. For example, we know 1997 and 8 we had El Nino. So, and we had a lot of satellite data and others. So we simulate real observed data obtained 1996 and give that data in the virtual Earth and check what happens. And we did many such experiments. After 1980s, we have a satellite system, so we have tons of data. And because of the nice activity of the operational agencies, we have a lot of nice, let's say, assimilation data, okay? And we use that. And we checked our performance of the skill to predict future. And this red one is from our groups. Others, very big institutions, but lucky enough, we just doing this only 3 or 4 people. Other agencies, many people, okay? Anyway, this is the 1 month later, and this is the 6 months later. And we correlate what happens, our prediction and the actual phenomena, and correlate. And the correlation is rather high, okay? So this can be used for future prediction, okay. Now, this is rather dangerous part of my talk. Let me show the future. Okay. Now, this is June, July, August this year. La Nina or La Nina model would over. Okay. And this is the temperature anomaly. This region, this rather blue, that means a little bit below normal, we predict. And this is a precipitation, India and this part. We predict rather less rain this year. Also, we are very much afraid of this near Japan and Korea. Meiyu, Bayu, your Changma, maybe bad one this year. And this is the September, October, November. We'll have the negative dipole. Negative dipole will evolve like this. Warm anomaly here. Okay? And the predicted June, July, August, this is November, December. Precipitation, less precipitation in this area. So I'm very much afraid of this area. Okay? Anyway, there is a rich application of climate prediction to society. And industry and society in Asia and also Pacific is highly vulnerable to abnormal weather, extreme events induced by climate variations under the changing climate or pressure of the global change. So to mitigate impacts from the extreme events, our seasonal projection, also other agencies working hard, that kind of system by use of the ocean atmosphere coupled general circulation models based on validation studies is quite useful. Just directly go to the global change, sometimes dangerous, because scientists must also have the validation studies. Weather forecast progressed so much after von Neumann started with Jules Cherney, 1950. Because of the everyday validation and the seasonal forecast, every season will be checked. And I predicted, I warned this summer conditions. I might be wrong. Actually, that is validation, okay? You validate. And then we will work hard and ask government, ask society to donate money or government. Then we work hard and improve our climate models. In that way, society and scientists can interact. So this kind of activity is very much important. That directly go from the climate change to the abnormal weather is dangerous. In between, very important climate variations, we must spend equal energy to the climate variation research and prediction study. That is directly related to the human being societies. Okay, thank you very much.
Thank you, Professor Yamagata. And after the second talk, then we will discuss together, okay?
Okay.
Yeah. And the second speaker is Professor Chowdard from National University of Singapore, and he's also the president of International Union of Material Research Society. He will introduce us how to transform this knowledge and how to share from developed techniques and developed countries to developing countries. And he'll show us many examples for doing that. So please, Professor Chowdard. Yeah.
Good morning, everyone. First of all, I would like to thank the organizers for giving me an opportunity to share some of my personal thoughts with you on a topic of global importance, enhancing international collaboration in cutting-edge science in Asia Pacific. In fact, this title is not given by me. This is the title suggested by Norden, and the reason being, I am associated with a few of the professional societies, both in Singapore and worldwide, and I am also associated with the developing bilateral relations between National University of Singapore, from where I come from, and the Indian universities and institutes of higher learning. And in the process, essentially, I could say that I have learned something, how to bring the different people together, how to share their knowledge, how to work towards basically or collaborate. That's the reason why Norden has suggested probably I should talk about this. So this is a non-scientific talk on science, that is cutting-edge science, and this is supposed to be basically applicable for Asia Pacific, but it is not necessarily what I say is only for the Asia Pacific. It could be for any region in the world. So in this presentation, I will touch upon two different aspects. One, what approaches the governments or organizations, whether it could be academies, whether it could be ministries, whether it could be regions, what kind of approaches they should do or take to adopt or carry out the cutting-edge science. Then, of course, what are the basic requirements to enable this cutting-edge science? In the process, I will touch upon few aspects like education, research, innovation, and international collaboration. Now, of course, the title is Enhancing International Collaboration in Cutting-Edge Science in Asia Pacific. The word enhancing obviously implies that we do have the collaboration going on. No doubt it is there, otherwise we would have not been here. We are all here to share the knowledge, to share our expertise, to help each other. That's how we are collaborating. But however, I would focus on two aspects, that is international collaboration and cutting-edge science. Before one embarks on cutting-edge science, one should be clear on the goals, what this cutting-edge science is expected to provide. Improve the quality of life and assets of the residents of the region, if you are talking about ASEAN or Asia Pacific or Asia as a whole or the world, whatever it is. Improve financial and physical security of the region, and more importantly, improve quality of life and assets of the people outside the region. You can't be really comfortable when your neighbor is not equally good. You are always in danger. So whatever we do in the region, it should also be helpful for the people outside the region. Then of course improve long-term stability of global economy, health, environment, peace, and many other things. So obviously these are the various things what one should look for. These are the implied goals of the cutting edge science, and particularly the item number 3 and 4 is the prerequisite to succeed with 1 and 2. Now, having understood what are the implied goals, then naturally we should know how to achieve them. Most important is any organization, first of all, have the trust in the science. We should make sure that we should be confident that the science is the one that is going to deliver the goals, and imagine a future in which the pressing problems could be solved by the science. That fundamental requirement. Having got trust in the science, cutting edge science, then naturally we cannot solve all the problems at one time. We have to prioritize what is more important, what is most important, what is timely, what should be handled first. These are the things that should be looked at first. Then of course, what type of science is the one that we should look for? Are you looking for some new basic science or invention? If so, in which field? And what are we looking to develop the new products or techniques that suits the given region, or adapt or scale up the existing cutting edge developments to scale or price point of view? So we should be very clear on what are the approaches that we should take to solve these prioritized items. Then naturally, what are the things to be done by the government or the funding agencies or the ministries? Provide direct research funding. That is, you must provide the research funding for a given particular project. Then also provide financial incentives for industrial consortia working to develop marketable cutting-edge products to suit the regional and global market. Of course, we have to encourage regional entrepreneurs to adopt new and improved technologies. And then the next thing what we need to do is the accessible education that is basically designed to provide the required scientific manpower for the region. Then public education is equally important. Whatever the government or organization or the ministry, whatever they do, they need the support of the public. You have to convince the public what we are doing is for their good. So the public education to promote the informed interest and support for the new technologies from the community, including expanded science literature, is the most important thing. So more importantly, you can't solve the problems overnight. So obviously we have to have long-range planning. It could be 10 years, 20 years, 30 years, or even more. So for this, we need to have some trustworthy predictions. It is very important for today's action decisions to be based on trustworthy predictions of the regional and global environment. It could be physical, technical, social, demographic, and economic. So the critical component of any cutting-edge science portfolio must be the emerging science of informatics. That is the one that will tell us or lead us to the future. If the informatics science is wrong, if you are not able to make the good predictions, then the whole thing will go wrong. So we need to have a rather focus on the science of informatics. And we need to have the systems that can reliably gather and aggregate the data about the region and the earth, and these are the things that must be developed as a whole. Of course, no individual country or a region can be on its own solve all kinds of problems. So we need to have the international collaboration. So for this, we need to begin with a comprehensive region-wide discussions about the local wish list. That means every country has its own priorities. We should have that list first to start with. Then, for the region as a whole, generate a similarly prioritized wish list for the region. Then, of course, we have to see what is the impact of each of these, whether it is a local, regional, or global. So this is a step-by-step process, in other words, before one embarks on so-called cutting-edge science. So we have to know our goals, we have to know how to achieve these goals, what type of priorities we should put in, how the region or the countries in the region can work together, and these are the different steps that one need to follow. Having done that, having understood the basics, having done the homework by the government or the academy or the ministry or even an organization like ICSU, now we have to understand what are the basic requirements to carry on cutting-edge science for the benefit of the mankind. Now, obviously, the education. The education could be a general education in the sense to develop the skilled manpower. It could be public education, that is to bring the public in line with the government policies and by their support. So these are the things what have to be done first. Similarly, the research. The research could be both basic and applied, and because the applied research is the one that leads to the technology. And then of course innovation, which is obviously the technology oriented. And for all these things, of course, the international collaboration is the most essential part. So you could see the education is the one that provides support for the later things like research, innovation, and of course international collaboration is the enabler in all these three. Now coming to the education, coming from the university, we have a little more passion for the education than anything else, and particularly there's a great change in the education pattern today. Our world has changed, particularly in the last 2 decades. It's all due to the globalization, and everybody talks about globalization, but it has a great impact on the education as a whole. That is, it has integrated the national economies. No economy of any country can stand on its own. For example, you have a technology in one country, skilled manpower in another country, and these two together can help the third country to develop. So there is an integration of the national economies that is all due to the globalization. And of course, now through the internet, mobile phone, social networks and so on, the world has become really smaller. It is all brought together, the whole world has been pushed together. Now interconnectedness has increased and people are pushed much more closely together. This is what has happened due to the globalization. And the net result of this is the rise of the knowledge societies and economies. In the context of the knowledge-based economies, of course, the universities or institutes of higher learning have a great role to play. And they have to change their education pattern itself. They have to provide a transformative global education. And they have to create impact through research and its application. They can provide thought leadership. It's not only the institute, even academy, for example, science academy. Because if anything, the politicians, governments look at the academy. And the academy is supposed to provide the thought leadership. These are the things that what we need to really focus on. And in the end result is the universities or institutes of higher learning should become more global institutions. And global education at a university essentially means preparing our graduates for a globalized world, not localized world. So how do we do it? We provide broad-based education with multiple pathways. When we say broad-based education, so we are not going to train the students for the career, for the whole life. Instead, it should be life of careers. He or she should be able to change the career. So we have to provide really broad-based education. And similarly, multiple pathways. That means for some reason, if someone has boosted the board to start with, it doesn't mean for the whole life he or she has to pay the penalty. Suppose you join a polytechnic, you should be able to still end up with a good degree in the university. You should provide the multiple pathways. And you should also provide the diverse learning community. That means we should have the international student participation together. you learn a lot from your neighbors, from your colleagues, from your peers, and so on. So that is what we mean by the diverse learning community. So for this, we have to have innovative global education programs. How do we get to this? Of course, we have to provide overseas exposure for our undergraduates, maybe for 6 months or more, and lead to some joint or double degree programs with top universities, and also probably have some overseas colleges where the innovation could be encouraged, in the sense where the students could be trained in a company or industry, and at this simultaneously take degrees, learn expertise. At this stage, I am going to share with you some of the experience of the National University of Singapore, about which I am familiar, working there for the last 30 years. I can say more about it. I have gone through the development of the university all these years. Those of you who know the National University of Singapore, 30 years back it was only a name, but today it is a brand. So in other words, you can see it is a different situation altogether. I have seen the progress, so I will be sharing some of the experience. By no means that is a unique experience, but it could be a learning curve for others. For example, when we are talking about the global partnership, international collaboration, and so on, what the National University of Singapore is doing or has done, will be doing, is to have partnership with a number of reputed universities. For example, we have Duke, a US graduate medical school, where the students are admitted directly to the Doctor of Medicine, MD program. Similarly, we have Singapore, MIT Alliance, and with the MIT, the Logistics Institute Asia Pacific, with Georgia Tech. We have Masters in Public Policy with Columbia or London School of Economics, Masters in Public Management with Harvard, and so on. What is that I am trying to put forward? International collaboration is the most important. And what is the purpose of it? To share the expertise. We recognize that the National University of Singapore alone cannot provide everything. We have to learn from others. We have to provide. We have a partnership. That is going to be a win-win situation. That is what we are saying here. This is applicable for any university, for any country. We can learn from other experts. So it is a question of sharing the knowledge. That's where the international collaboration comes in. Similarly, earlier I mentioned that we do have something like overseas colleges. We have set up the overseas colleges in different countries. Silicon Valley. So the students go to the Silicon Valley and work in the industry there, study in Stanford University, they take the credits for it, they come back. In the process, when they come back, they are in a position to start new companies. That is innovation. They are learning from the fundamentals from the good companies there. So they are based in, for example, Silicon Valley companies. Similarly, the Bio Valley and the University of Pennsylvania, Shanghai University and Fudan. And like this, Stockholm, Bangalore, India, Beijing, Tsinghua. So what we do, we do 1-year internship in a technology-based startups, attend courses at partner university. This leads to innovation. In fact, I can say over the past few years, the people who have been there, have come back, have started almost about 150 companies within Singapore. So this is again, I don't mean this is the only approach, but this is one of the approaches. This could be a learning curve for others. So the net conclusion I'm trying to draw from here is to educate our students, to transform them from the local setting to a global setting. And when you are talking about a global setting, particularly it is going to be a multicultural setting. One from the Middle East, one from Europe, one from Asia, one from Africa, maybe sitting together on the same platform, learning together. In the process, it contributes to the better understanding of the people, better understanding of the regions, and leads to the global peace and prosperity. So this is again a basis for the international collaboration. So another point I would like to bring up is, apart from the universities changing their own education pattern, changing from the local setting to the global setting, we should also become the nodes in major academic alliances. In fact, ICSU has been talking about the outreaching to the various organizations and so on. So for this, one approach is you have to be the member of the major academic alliances. And in the process, essentially, it is going to be a mutually beneficial academic outsourcing. So it helps each other in having partnerships, in being the member of the networks and so on. That means we are going to capitalize on complementarities through academic partnership with overseas institutions. This is something which will be of great importance for the ICSU or for any professional organization. In this context, again, I will share with you the partnerships what we have with various international organizations. For example, NUS is a member of the Association of the Pacific Rim Universities, and it hosts its secretariat. And NUS is a member of the International Alliance of the Research Universities, is a member of the Asia Pacific Association for International Education, ASEAN University Network, UniStars 21, Association of Southeast Asian Institutes of Higher Learning, Association of Commonwealth Universities, and more recently, it is a member hosting the Secretariat of Global Enterprise for Micromechanics and Molecular Medicine, for which I am also the Executive Director, apart from the NUS India Research Initiatives. Again, I will share my experience about this so-called GEM4, the Global Enterprise for Micromechanics and Molecular Medicine, and that could be of interest to some of you. What is this GEM4 does? Actually, it is a virtual institute. It is only meant to international collaboration, and we have several participating institutions, right from Caltech, Georgia Tech, MIT, University of Illinois at Urbana-Champaign, Columbia, Duke, Harvard, and so on. The institutes are listed there. What is that they do? This organization has brought together researchers and professionals in major institutions across the globe with a distinctly different but complementary expertise and facilities to address significant problems at the intersection of the selected topics of engineering, life sciences, technology, medicine, and public health. So it is really truly interdisciplinary organization, and only the office is located at Singapore, but we have researchers all over the world. They share the facilities, they share the expertise, and they have common goals basically to solve the problems for the mankind, like medicine, technology, life sciences, and so on. So it is a cross-fertilization of the ideas among the engineers, because essentially here we are sharing the facilities, we are sharing the expertise, but not much money is involved. It is only an understanding among the various organizations. Today, someone from MIT can walk into the National University of Singapore without any approvals required and say, I would like to use these facilities, vice versa, because we have an understanding. So this is the organization that does. This is the one that is really helping for the international collaboration among the researchers to be able to do so-called cutting-edge science. So effectively, the educational reforms in terms of the joint and double degree postgraduate training can give exceptional academic value. In the process, we are exploiting research complementarities, and we are going through the mutually beneficial academic outsourcing. Of course, it is also helping each other, the organizations and the different parts of the world, to attract high quality students. Then I come to the research part, and research is unending, the problems are unending, and they can never be solved at one time by one organization. So that is the only hope that keeps all of us going forever, because we can continuously say we are continuing to do research, solving the problems and so on, and apply for the research grants and so on. And I cannot dare to list so many problems, but I will just talk on one part, that is energy. Particularly, I will focus my attention to the ASEAN region. This is only a typical example, but it could be applied to the Asia Pacific, it could be applied to the whole Asia, it could be applied to the whole world even. So what is that I am trying to say? The different parts of the country, or the region, say ASEAN, have different resources. So we have 10 different countries, and different countries have different resources. One is rich in oil, another is rich in gas, another is rich in something else, and Singapore is rich in nothing. It doesn't have any resources. Okay? So we have really dealing with different types of the people, but there is still a way of working together. Suppose if you look at the coal, and Asia Pacific is about 30% of the world coal, and ASEAN is only 0.7%. So in other words, ASEAN will be the net importer of energy sources in due time. And of course, energy security is a concern. Similarly, if you look at the oil, again, Asia Pacific is only 3.2% of the world production, and ASEAN is only 1%. Again, it is a real problem for the ASEAN. It will continue to be the net importer of oil, and sustained energy supply is a concern for all ASEAN countries. And if you look at the gas, it is again similar situation. Asia Pacific is only 9%, and ASEAN is only the 4%. ASEAN will be the net importer of the natural gas in due time. So what is that I am trying to say? Again, different countries have different resources, strengths and weaknesses, and there is a great opportunity for them to work together. Now coming to Singapore, as I said before, it has no resources, but it has only the human resources, only about 5 million people. And it is supposed to be most innovative country, but it is spending quite a lot on the fuel cost. That is fuel. It's about $10 billion it is spending. But at the same time, it is a unique situation in the sense it is a real energy hub. It is a oil trading hub. It is the largest in Asia and third largest in the world, and the third biggest oil refining center and the world busiest bunkering center, and so on. So effectively, Singapore is trying to really look at the energy security and trying to import the resources from the other countries. There is a great opportunity for the people in the region to work together, and that can happen only through the international collaboration. And particularly our challenges in Singapore is of course economic sustainability, and that is to safeguard the energy security, energy, natural environment, and so on. And this whole scenario has changed from the labor intensive to the knowledge and innovation based economy. And so in the process, essentially, there are several drivers for the change. That is a limited land, no natural energy sources, we don't have coal, oil, gas, or anything. And so obviously, these are the ones that are contributing to the new opportunities for the potential research areas for collaboration. That is energy security options, enhancing energy efficiencies. All these are the various aspects what we are looking at, and there is a great opportunity for the region to work together through the international collaboration. Now, one last thing I'm going to say is, of course, we are talking about research collaboration, international education, and so on. In the process, again, my office is looking at certain things, basically hoping that these will lead to the so-called cutting-edge research and international collaboration in cutting-edge research. Particularly, this is the one applied to India. We have several MOUs with the IITs. We have joint degree programs with the IITs. We do organize bilateral symposia, and all these things are leading to research collaboration. And in the different areas of the research, particularly we have developed research in the nanotechnology, biotechnology, and various aspects. This is one aspect that what I would look to. And actually, I don't have much time. I also wanted to touch upon the biomedical sciences. Particularly, the reason why I want to touch upon is each region has its own strengths and weaknesses. So we have to cash upon the strengths of the region. For example, if we are talking about biomedical sciences, and human health and disease is one of the most important global issues, everybody knows it. And particularly, the drug discovery companies have different approaches now. Even the small players, new players have a role to play. And particularly coming to the Singapore, of course, we have 3 Asian ethnic communities. The reason why I brought out these, and it is said that the global burden of disease is shifting to Asia. By 2030, 50% of the cancer patients are expected to be in Asia. So anything related to the medical research, it has to be the region-oriented. We have to cash upon the advantages of the assets of the region. For example, we have different ethnic differences in biology and response to the treatment, etc. These are road-well studied, and we have to take advantage of the presence of the multi-ethnic people in the region and look for that. And for example, I just take one example of the cancer, and if you look at the Singapore, the top 5 cancers, the most serious one is the lung, whereas in the America, the most serious one is the prostate cancer. So it is again different for the different regions. So we have to really cash upon these things, and this can be done only through, of course, the different people respond differently. We can't use the same medical dose for a person of the Asian origin, what is applicable for the people of the US or other countries. So that is the response is different. And of course, there is a growing research funding in Singapore. And as you could see, we have about $16 billion funding available for the next few years. And there is a great opportunity for people to share this kind of funding. And for example, coming to the biomedical research alone, we have grown over the years. We started small institutions, and eventually we have a number of institutions that have come up, and clinical research is also made part of the studies, part of the university system itself, and essentially the important manifestation of the changes is teaching hospital and university are together, and this is helping a great deal in really solving some of these problems. And to give you an example, what kind of international collaboration we have, if you look at the photos, what you see there, they are coming from all parts of the world. That's where the international collaboration is coming up, and we need to work together basically. And the last thing I would like to bring up is you can do good research, but you also need to publicize, bring the people together to the common platforms, and we do have different approaches for this. One is the International Conference on Materials for Advanced Technologies, and actually it has grown to be one of the largest conferences of its kind in the region, and over the years we have attracted several Nobel laureates. They turned out to be the pool for the attraction, calculus and so on, and this is where again people can work together, come together and learn from each other and lead to the international collaboration. And of course, innovation is the one thing that's the most important thing, but most difficult thing also. And so, in my opinion, a good university, public sector research organization, and industry have to work together to go for the innovation. And these industries or the companies have to tell the universities where are their challenges and engage the university to solve their specific problems. We need to accelerate the rate at which research goes to commercialization, and global alignment in curriculum development, so setting aside some time for the industry attachment is important, and co-investigation both locally and internationally is the key for the success. That's what I would say. And to conclude, the Asia Pacific should take advantage of the different energy resources available in different countries for energy harnessing, and different ethnic groups living together for the medical research. And of course, the Asia is growing, the growing economic prosperity of the region. Of course, through this, more funding for the research should be made available, and we all have to work together and lead to the international collaboration for the good of mankind. Thank you.
Thank you, Professor Chowdard. You may sit at the table. And Professor Yamagata, please come to the front table. So we have 15 minutes for discussion and closing remarks. So I come to the other table. And we have first 10 minutes for the question from floor, and then The speaker will give the answer, then we will discuss again.
That's a great talk by both of you, actually, and I'm going to pose questions to both of you, I guess. You would agree with that. To Professor Yamagata, of course, global warming and climate changes are happening, and we know that they're going towards the worst. What is the scientific basis for all this that is happening over the years? And how does, as a scientist, I justify that this global warming or El Nino is going to lead to disasters, going to lead to changes in temperature? Now, if I consider this globe as a closed system, and if I bring out the famous equation of free energy, where the entropy and enthalpy is changing, could this be used as a model to understand that if the free energy is changing or is becoming negative, then obviously it's an interplay between, let's say, enthalpy and entropy. Would you like to comment upon this? Because this is, I know it's a very complex system, but if we see globe as a closed system like what we see in thermodynamics, could you please explain to me whether some correlation can be built around this?
It's a very difficult question, but this whole Earth system is run basically by the solar radiation. So thermodynamics is very, very important. And the solar insolation, Earth accepts changes because of the orbit and the also precession and others. And we have a Milankovitch cycle, and all scientists basically agree the ice age interglacial period is related to that. But that kind of signal is enhanced by the ocean atmosphere and the land interactions. And that part is, in some sense, natural variability. And some aspect, because of the release of the global warming gases, some aspect is changing. So I explained the natural variability, also extreme events, through natural variability. And behind the scene, we have the, let's say, anthropogenic effects, such as release of the global warming gases, also loss of the, let's say, tropical forest, and a lot of man-made disasters. And so, as a whole, from the, if we look at the Earth far away from the universe, basically nothing changes in some sense, except for the radiation changes. I don't know, this is answer to your questions.
So my question is that the entropy in the globe
Yeah.
is increasing.
Yeah. It's as a whole, it's a galaxy and the basically one way, I think. Entropy is growing.
It's a wonderful idea to have a global system of education and learning. And I think it's a great thing that University of Singapore is doing. I think from the sustainable point of view, today if you look into nations are doing a lot of things individually. I mean, if you take every nation is trying to do things and duplicate things. Some of them do not even have the requisite skills, and they're trying to address a problem. So today the science and technology, actually, if you look at, we need to address the problem of globe. It is no longer, to a very large extent, remains the problem of nation alone. And therefore, the science and technology needs to be integrated globally. And I completely agree with what NUS is doing, but I have certain concerns or other questions, I would say. See, you have actually tied up with some very outstanding institutions in the West. Now, if you look into the Western world, today Western world is looking at the emerging economy in the Southeast Asia. And obviously reasons are very, very obvious. Now, what would happen really is, I'm not trying to blame NUS for what they're doing, I think they're doing a great job. But my concern is that, how would this really help the Southeast Asian region? Because remember one thing, that the demographic advantage is today in favor of these societies. The democracy in the favor of these particular countries like India, China, and of course Southeast Asian region. I think we need to build a very robust system of integrating science and technology, whereby these nations do not duplicate. They actually integrate their knowledge to really address the problems of globe. And I would think that here, through various forums, including ICSU, NUS has taken a lead, where actually some of these knowledges that are going to come through this participation should be integrated through to this part of the world. Then it makes a lot of sense. I think doing independent science and technology also has a very big burden on sustainability. Because when I work in the area of, let's say, material science, 10 other countries are doing the same thing. How does it help the globe? I think if we focus our energy on doing something very specific in a collective manner, so that others can take care of other part of science and technology, and thereby release the burden on sustainability. I think the world must go towards a direction where sustainability, or rather what science and technology we do, sustainability must kind of drive that. Then I think we are going towards a global system where problems of climate, problems of sustainability would be taken care of. So I want you to just give me an answer to some of these questions I've raised. Thank you very much.
There is no doubt that we all have to work together, look at the regional problems. In fact, it is true that we do have some understanding with outstanding Western universities, but it doesn't mean we have ignored the Asian universities. We have University of Tokyo, we have IITs, we have University of Hyderabad, we have Tsinghua University, Fudan University. In other words, in the regional universities are very well taken care. The purpose is basically to work together to solve the common problems so that we don't duplicate the efforts. That is true, that is the whole idea. But at the same time, recognizing that the West has already developed a little much ahead of the Asia, and we are only talking about Asia becoming the node in years to come. So we do have, there is nothing wrong in learning from the West also, and use it for the good of the our own region. That's the whole idea of having, sometimes we have even the trilateral relations between NUS and, let us say, China, Tsinghua University in China and MIT in US. So this is how we try to solve or understand each other's problems and take advantage of the expertise of each other. Thank you.
Yeah, it's question first from Malaysian Science, Academic Science, okay.
I have a question for Professor Chowdhury. In fact, to follow up on the previous speakers, follow a previous question is related to that. My question is, in order to implement your international collaboration program over a diverse area of many countries with different government policy, educational policy, and also different culture, different languages, and so on and so forth, what do you see is the biggest stumbling block or barrier to the success of such a program, to gel all this, what you call that, the collaboration together successfully? Thank you.
It is a very important question in the sense, there are stumbling blocks, there is no doubt about it. The stumbling blocks are basically the common understanding and respect for each other, respect for the expertise of each other, and our dedicated mind to work together. If these can be solved, if people decide to work together, if they understand each other very well, and if they can share their resources, definitely it can be done. But that is the stumbling block, and the only solution for that is a common forums like this, for the people to be brought together, made to understand each other, and nothing equivalent to meeting face to face and discussing and becoming friends and eventually working together. So these are the only ways, and not that we are denying about the stumbling blocks, everybody knows about it. We have to work together for this. This forum is most important in that sense.
Then we will have that teacher board before, and the last is the
Madam Chairman and the members of the panel. My question is directed to Professor Yamagata. Now, we have used the ocean atmosphere as a means to predict climate change. I just wondered why ocean atmosphere, why not terrestrial atmosphere? That's one. The other question is in terms of El Nino, El Nino has always been associated with crop loss, and this has been quantified. But I've not seen data to indicate the effect of this climate variations as far as the effect on the biodiversity of the marine ecosystem. Are there such a data in terms of losses of fisheries and all that? So those are my two questions.
So you mean terrestrial impact, right? First question, right? Yeah, terrestrial land process. You mean land process? Ocean atmosphere. Yeah.
Can we use the terrestrial atmosphere?
Yeah. Land is important. Of course, I didn't discuss much about that, but this couple also includes land processes. Land processes are also important. Three major components, but I just focus on the atmosphere ocean because El Nino is basically Earth interaction, and I focus on that. Monsoon is certainly a land process, very important. And the second question is that kind of climate variations also have a great impact on the biodiversity, such as the eucalypt in the northern part of Australia. Eucalypt already knows that. And so every 5 or 6 years they have a forest fire, and utilizing that nutrition, and that seed grows. So some part already inside the gene of those plants. At the same time, but the magnitude of the also frequency is changing, and that certainly gives serious impact to the biodiversity, from my viewpoint.
Thank you. And then the last question from Steve.
Thank you, Chair. My question is for Professor Yamagata about the seasonal prediction system and engagement with the public. So, many people, I think, are aware that British people are completely obsessed by the weather. And if there's one thing that they're even more obsessed by, it's about telling the Met Office that they got the weather forecast wrong. Now, there is, the Met Office in the UK does have a seasonal prediction system, but, which has skill, but they've had a lot of difficulty from my perspective in communicating with the public what the outputs of such a model means, as opposed to a more traditional weather forecast, which is somewhat different than the public are used to. So much so, and I would say that they made the old communication mistake as well, but so much so that they're now not publicising the outputs of the seasonal prediction system to the extent that they were, because they were finding it difficult to communicate. From your perspective, from your experience in Japan, are there lessons to learn as to how best to be able to communicate the outputs of a prediction system of that kind, as opposed to the daily sort of weather forecast that we're used to? Thank you.
Thank you. Very interesting question. The communication with the society, but before that, we have a serious problem of the block between communication between our R&D groups and weather forecast bureau. because they are extremely conservative and very slow to accept cutting-edge science. And that's my serious problem with the Japan Meteorological Agency. And I know many friends, I have many friends in the Met Office, but I shouldn't say the exact name, but they also say complaint. Anyway, but it's a challenge. Like Chowdard, communication, enhancement of communication among different sectors is very, very important. And at the same time, there is some lack of science. I talked about the tropical regions, but mid-latitude climate, particularly seasonal forecast, still have a lot of things to learn, to study. And that's why I started using JICA money to do that kind of experiment in the southern part of Africa, South Africa. That region is much simpler compared to the northern hemisphere. Okay, thank you.
Okay, thank you very much. It's time to close. And then we have really the hot discussions. And I think although we deal with the climate change or biomedicals or technology or the energy problems, I think the most important is then how we then use this global as an infra system and how we communicate and then collaborate together. And I think the internationally collaborating being is the sunshine for us. And then I think then our regional committee of Asia and the Pacific should play the role for the welfare of Asia people. Thank you very much for your audience, and it was really great pleasure to have a nice talk with this prominent scientist. Thank you very much.
Thank you very much to both our distinguished speakers, Professor Yamagata and Professor Chowdard, for the excellent presentation and discussions. And to Dr. Hong Kam Lee as well for moderating the session. Ladies and gentlemen, we have come to the end of our program. Thank you very much for your participation, and we look forward to meet you again in our future programs. All guests are invited for lunch at the latest recipe restaurant, level 5. Thank you, and we wish you all a pleasant day ahead.